Okay, so we're going to talk about substitution to solve. This is a interesting method. So substitution more or less just replaces a variable with something that's equal to. So I like to do it this way. You get a variable alone, and then you go to the second equation, and you mark the same variable. Then you take what that variable is equal to and plug it in there. Maybe I should do it this way. Instead of doing a box, maybe I should think of it as parentheses. Or boxing this one, parentheses. I don't care how you think about it. This is going to go in there. So you end up with negative 4x plus 8 equals x plus 7, or I wrote it the other way. And then you solve that like normal, which I kind of went through the process down here. And we'll do plenty more. And then once you have the solution here, then I'm going to plug that back in for the x value and evaluate. Did I get the right number? 5x. Yeah, that's the right answer. So, not the prettiest, but they don't always have to be pretty, but we'll do the next one, and it'll be a little prettier. If I already have the variable solved for, it makes it nice and easy. So you see how the y is already alone. So on this equation, I'm going to take this stuff and put it inside that parenthesis. And then you evaluate, 7x minus 2x becomes 5x, right? Then the easy way to find the y, which I didn't talk about last time, is you take it and go back to here where you did the box. And I know y has to equal 2 times x. Well, if x is 3, that means y must equal 6. And I have my two solutions. Okay? We'll keep doing this. Now, if the variable is not alone, look at the equations, and you can see that there's a variable that is kind of alone. Well, to finish getting it alone, you can do this. Okay? So then, once it's alone, once again, I can do this. So then we distribute. Put those together. Don't ask me what I'm doing there. Simplify that to 5/4. So I take that and I plug it in here. And I might have done my math there wrong somewhere. But I don't think so. If I did, feel free to make fun of me. The idea is still right. What does that equal? 6. That'd be 30 over 4, which would be 15 halves. Which I believe that equals just a half when you put it together. Use your calculator to double check me probably. And there is my solution. So we'll look at the word problem here. There's a lot of examples here. I'm not going to do all of them. We'll look at the word problem real quick. So, school committee is planning a trip. 193 people to another school. 8 drivers. And they're driving buses or minivans. So if I add the buses and the minivans, that's to equal 8, because that's how many drivers I have. And we know that the bus holds 51. And then the minivan holds 8. And we know that there are 193 people going. So we can see that that variable is almost alone. So if I subtract the b, I get m equals 8 minus b. Plug it in. minus the 64. I'm going to put my b's together there, so I get 43b. That would be what, 130, 129, I think. So you get the buses equal 3, and then the vans would obviously equal 5. Okay. Once again, solving. This variable is already alone, so I'm going to use it. So all of this stuff is going to go in for that y. It's always easier to put a parenthesis, because then you remember that you have to distribute the negative. So x minus half of x would be negative half of nx. And then b minus 2 equals 1. Multiply by negative 2. You find that x equals a negative 6. Once again, I'm taking that, putting it right back in there. Half of negative 6 plus 2. Well, last time I checked, half of negative 6 is negative 3. So I get y equals negative 1, so I have my point. Okay, I don't know how many more of these I need to do. We'll just quit there. We'll do some more examples in class. You might have to find out how to do the word problem like this one, but you can ask me about it. And then we'll do it in class maybe. But if you have any questions, you can email me. Otherwise, have a good evening, and I will see you soon.